Today we are going to take a look at a question of Maclaurin series. We have this question given fx equal to cos inverse x, whereby x is between -1 and 1 and fx is between 0 and pi. We are supposed to show that 1 minus x squared f double prime x equal to x f prime x. For this particular notation, if you are not very comfortable with it, we can always try to replace the f prime x with dy dx, or the f double prime x with d squared y over dx squared. Then we will proceed to solve our question. After we have solved the entire questions, then we can replace back with the correct notation. But anyhow, I'm going to stick with the notation they have used. So we have fx equal to cos inverse x. Let's do a differentiation first. We will end up with f prime x equal to -1 over square root 1 minus x squared. Of course, for this particular question, we can continue to do a differentiation, but the intention for Maclaurin series is not like this. Usually, we will want to make use of some form of implicit differentiation to make our algebraic manipulation for the differentiation much more effective. So in this case, I'm not going to differentiate first. I'm going to first multiply the denominator to the left-hand side. I'll end up with a square root 1 minus x squared f prime x equal to -1. And if you want to do a differentiation from here, it's possible. But I find that usually when expression involves a square root, the differentiation process may get a bit messy. So maybe I'll just square the entire expression first to get rid of the square root. I'll have a 1 minus x squared. Then this is f prime x whole thing square, and this will be a 1. Now I'm going to do an implicit differentiation to this. I will be using a product rule for these two terms. I'll be keeping this first, 1 minus x squared. Differentiation of this one, I'm treating this like a big X. So when I differentiate, I bring down the 2. I'll have f prime x. Then after this, I'm going to differentiate again. I will have f double prime x. And now we will be keeping this and differentiating this. I will end up with a 2x f prime x, and I will get a square equal to 0 on the right hand side. And from here, I think we can do a bit of simplification. The 2 can be cancelled away, and I think we can also cancel away one of the terms from f prime x. Okay, so I will be left with 1 minus x squared f double prime x minus x f prime x equal to 0. Shifting this term to the right hand side, I will have a 1 minus x squared f double prime x equal to x f prime x. And this is what the question wants us to show in our first part. And second part of this question say by further differentiation of this result or otherwise, find the first 3 non-zero term in the expression of fx in ascending powers of x. And when the question asks for a first 3 non-zero term, probably I'm going to try to find what are the available values first before deciding whether we want to differentiate another time or not. Right? So maybe we will work out what is our f0 first. f0 I can obtain from here. Subbing x equal to 0 here, I will have cos inverse 0, which will give me pi over 2. And subbing 0 into my f prime x, I will have a -1 over square root 1 minus 0 square, which will work out to be -1. And for our f double prime 0, I'm going to use this expression here. Subbing x equal to 0 throughout this entire expression, I will have a 1 minus 0 square f double prime 0 equal to 0 multiplied by f prime 0. And this happened to end up to become a 0. And I will get my f double prime 0 to end up to be 0. And these are the only 2 terms I have for the first 3 non-zero terms. So unfortunately, we are going to need to differentiate this another time in order to get our f triple prime 0. Alright, so I'm going to do a differentiation here again. This part I'm going to do a product rule. So keeping this, Differentiating this, I'll have a f triple prime x. Now I'm going to keep this, differentiate this is minus 2x f double prime x. Here I'm going to use product rule. Keeping this, our x, differentiating this is f double prime x. Now keeping this, differentiating this, I'll get a plus f prime x. Now I'm going to substitute x equal to 0 into this entire expression here. I will have a 1 minus 0 square f triple prime 0 minus 2 bracket 0 f double prime 0 equal to 0 f double prime 0 plus f prime 0. And we can see that these two terms will end up to be 0. And f prime 0, I already worked out previously, I'll get equal to minus 1. So this is minus 1. So therefore, I can see that my final value of my f double prime 0 will just be equal to minus 1. So we have 1 value, 2 value, 3 value. This will form for our value for the first 3 non-zero terms. And making use of the formula for the Maclaurin expansion, I will have fx equal to f0 plus x f prime 0 plus x squared 2 factorial f double prime 0 plus x cubed over 3 factorial f triple prime 0 plus dot dot dot. This is the formula obtained from the MF27. Therefore, I will have fx, subbing in the respective values. This is a pi over 2. This will be x. This will be minus 1. This will end up to be 0 because f double prime 0 is 0. And this final term is x cubed over 3 factorial. And this value is minus 1 plus dot dot dot. Simplifying this, I'll have a pi over 2 minus x. 3 factorial is just 6. I will have a x cubed over 6 plus dot dot dot. So this will be my Maclaurin expansion for my cos inverse x. In the first part of this question, we already found the Maclaurin expansion for cos inverse x, which I've replicated the answer here already. In this second part of this question, we are given a diagram, which is a triangle ABC. Using this diagram, we are supposed to show that sine inverse x plus cos inverse x equal to pi over 2. Let me just draw the diagram first. This is a right angle triangle. This is A, B, C. This is 1. This is x. I'm going to assign this to be my angle alpha and this to be my angle beta. Using the secondary school triangles, we can see that cosine alpha will just be equal to adjacent over hypotenuse, which is x over 1. From here, I can work out alpha equal to cos inverse x. Likewise, looking at our angle beta, I can write that sine beta will just be equal to opposite over hypotenuse, which is also x equal to 1. From here, I can work out beta will just be sine inverse x. Right? Since we are looking at a right angle triangle, I will know that alpha plus beta will be also equal to 90 degrees. Alpha plus beta, I'm going to write down in the radian form, which is pi over 2. So alpha we already have cos inverse x and beta equal to sine inverse x. So therefore, I can just rewrite in this form sine inverse x plus cos inverse x will just be equal to pi over 2, which is what the question wants us to show. Alright, and we still have the last part of this question, asks us to find the series expansion of sine inverse x in ascending powers of x up to and including the term in x to the power of 3. So we are going to make use of this result to find the Maclaurin expansion of this. We already have the Maclaurin expansion for cos inverse. I think to find this, not a big issue. I'm going to shift our cos inverse x to the right hand side of this expression. We will just have a sine inverse x equal to pi over 2 minus cosine inverse x. And from our first part, we already obtained the Maclaurin expansion for cos inverse x. I'm going to replace this with this series, pi over 2 minus x cubed over 6 plus dot dot dot. Expanding out, I will just get x plus x cubed over 6 plus dot dot dot. This is just my required answer for the expansion for sine inverse x.